Hello, everyone. Warm welcome from the Google team here to the NASA Space Apps Challenge Hackathon contestants. Looking forward to seeing many of you in person when this kicks off. My name is Rama Fulo. I'm a global program manager here at Google within Google Cloud, and I'm joined by Steve Moran. Steve.
Hi, I'm Steve Moran. I'm a strategic partnerships development manager in Google Geo Sustainability and cover all of our sustainability products and solutions.
Great. Thanks, Steve. So we'll be taking through a quick synopsis of why Google Cloud for Space makes sense for you. So we have a long history of working with space partners from primes to government agencies and new space. And we have an open sort of unified multi-cloud platform powered by Anthos. Uh, Google Cloud is known for its applied analytics, AI, and machine learning to solve real space data challenges as well as any other vertical. And we work with a growing set of ecosystem partners. You might have heard that 70% of all Gen AI unicorns are actually built on GCP as of a month ago. We have a commitment to security, compliance, and sustainability. Steve will touch on Google Earth Engine and some of our sustainability-focused APIs as well. And we have the power of the Google network, our edge compute capabilities, and we'll also offer to you cloud credits. So as a part of the NASA Space Apps Challenge, you have the ability to run workloads using $300 in free Google Cloud, Firebase, and Maps credits over the hackathon weekend. So you can run these workloads for free. If you just go to cloud.google.com/free, you need to have a valid credit card. You must be located in a GCP territory. And if you've never been a paying customer of Google Cloud, Maps, or Firebase, and you haven't previously signed up for the free trial, you will be eligible for this. So with this free trial, you get access to 20 plus free products for all customers, get a financial boost of up to $300 in free credits, and you can start deploying pre-built solutions for free, including deploying a website, launching a virtual machine, building a third-tier web app, and more sort of pre-built solution templates. So some of the top challenges facing companies in 2023 are listed here. I'm not going to go through all of them, but we can see some that stand out for me include sort of navigating regulatory hurdles, which is very prevalent within the space ecosystem when ITAR comes to mind, for example, and focusing on the technology required for the mission itself rather than the overall environment of the mission, which is what Google Cloud makes so accessible to all those who build from GCP first. So by partnering with Google Cloud, space companies can harness the power of Google, and we've gone through a lot of these. Then we've got a real expansive network of partners, as well as a number of apps and products that span well above the $1 billion active user mark, which means that we've got so much data to work from. And we built Google Cloud initially to support our own internal Google offerings. We've got a commitment to open source to continue to build. Our cloud AI portfolio is built to support the needs of Gen AI-centric enterprise development. Most Gen AI companies right now that are successful are choosing us. Vertex AI stands out here with our Model Garden, Gen AI Studio, and Gen AI APIs to help you sort of build, because this is an end-to-end machine learning platform that we've put together, particularly for developers, but we also have sort of all practitioners and business users touching in on this, and we've got access to our GPUs and TPUs also. Over to you, Steve.
I'll go through these quickly. I wanted to talk about 4 APIs that we've got that you may be interested in for the hackathon. Google Earth Engine, for those of you who haven't heard about it, is a cloud-based platform for planetary scale geospatial analytics that brings Google's massive computational capabilities to bear on a variety of high-impact societal issues, from deforestation to drought and agriculture to water management, climate monitoring, etc. Earth Engine enables you to compute on petabytes of data. We have over 100 petabytes online right now. And it lets you do that on the fly without having to navigate the complexities of cloud-based parallelization, etc. And this has really helped spur the growth of geospatial analytics at scales that just have been unimaginable in the past. I'll talk about 3 new APIs that we just introduced under the Google Maps platform. One of them is our Solar API. It puts our expansive data in mapping and computing resources to use to help estimate renewable rooftop solar energy potential and savings, and actually designs rooftop solar installations for you. We've released it in all 50 US states and in over 45 countries, and are working to bring the rest of the world online. On the another one of the Google Maps platform APIs is air quality. This is a global air quality model. It helps developers leverage real-time, accurate, and visual air quality information to help their end customers take action to adapt and increase their resilience to the effects of climate change. And then the last one I'll talk about is the Pollen API, another global model that helps developers empower their end customers suffering from things like seasonal allergies, COPD, asthma, by leveraging daily, reliable, and visual pollen information for the end users to help them understand the impact of this on their health. Well, back to you.
Great, thanks so much, Steve. So with that, there's so much more to Google Cloud and Google Maps and Firebase, but just want to leave you the note that we have a history of working with national and regional space and government agencies. Feel free to email us if there's anything that you'd like to discuss. Looking forward to seeing you during the hackathon. With that, I'd like to say thank you and best of luck.
Good luck, everybody.